Hello, everyone. My name is Oksana Sannikova, and I'm Security Enablement Technical Architect. Welcome to the last session of the Security SCVT mini-series. This is the last preparation session for the upcoming physical event that you're all welcome to attend either in person or virtually if you were invited. And today we will cover advanced malware protection and threat grid, as well as web security portfolio. The session will be focused on messaging, positioning, and design considerations. No roadmap or any future developments will be covered in the session today. This is just a refresher for you guys to get you prepared for upcoming event. The roadmap and the futures will be covered at the upcoming VT. And I would like to welcome our presenters, Daniel Bates and Smith Singh. And we will also have several people helping us with the Q&A today. Those are David, Tim, and Suma. And a few housekeeping reminders for you guys. Please use the Q&A panel for all of your questions so that Q&A managers can help you out with them directly. Do not use chat or Jabber for your questions. We will also save all your questions, and this call is scheduled for 90 minutes. Each part of the presentation will be 45 minutes, and towards the end of the call, we will ask you to complete the survey. Please provide your feedback. Please provide your comments. Those are very important for us to understand what's important for you in your job. The call will be recorded, and it will be available on Self-Connect and on partner security community pages within the next 7 business days, along with the presentation. So you will have the recording as well as the presentation available for you. And we will share the links towards the middle of the call. With that, I would like to pass over to Daniel to begin his presentation. Over to you, Daniel.
Thank you, Oksana. And hello, everyone. Welcome to the Cisco AMP and Threat Grid session on messaging, positioning, and design. Today, we're going to cover messaging, AMP, and Threat Grid. What is the go-to-market for each of these products, and as well as how to design them for both public cloud and private deployments. So just as a note, like Oksana said, we're not going to cover any roadmap or future development during this session. Please attend the SCVT for all that information. And I have Q&A managers that are able to take your questions and answer them while I'm talking. So with that, let's go ahead and get started with messaging for both AMP and Threat Grid. So most of our customers have invested significantly in concepts like defense in depth with perimeter protection, access and identity management, email gateways, web proxies, endpoint security. And this makes a lot of sense. It's made a lot of sense in the industry for decades, but today's community of hackers and threat actors are creating advanced threats and launching them into targeted organizations through a wide variety of attack vectors. And these attacks can evade even the best prevention tools. The problem is that each layer of the defense in-depth approach is that they each use a binary approach to threat detection. It's either good or bad. It's either block or allow. But as we all know, threats have evolved, and they can often hide in plain sight. So while most security vendors out there in the market space today are point products, they're trying to sell customers on 100% effective security. All you have to do is buy this one box, and you'll be protected against all threats. And we all know, and many of the customers know or have realized that that's really a fallacy. There's just no way to block 100% of threats 100% of the time. And what happens when something gets missed or when an incident turns into a breach is it costs their customers a lot of money. The current figures for the costs per record breached are up to $225 for American customers. Per record, and that's up from $221 in 2016. These costs are only going to go up. The total cost to remediate the breach, and that's going to be help desk activities, inbound communications, investigative activities, working with law enforcement and other agencies, remediation, legal expenditures, and so on, is $1.5 million for an average breach. And of course, lost business opportunities. 23% of organizations are losing business as the result of a breach due to loss of customer confidence and other factors that total up to about $4.3 $1.13 million per breach, and that's significant. So what can we do about that? Well, we have a fairly simple vision to deal with these advanced threats. We need to provide a single threat-centric control plane across the infrastructure to continuously monitor for these threats. So let's take a look at where AMP comes into that. There's really three key benefits that a customer will derive from our AMP Everywhere concept. The first is it makes the unknown known. And if it sees a threat in one place, everyone will get protected everywhere, regardless of if they have ever actually seen that threat. And finally, it gives organizations unparalleled context to accelerate security response. Well, what do we mean by each of these? Well, first, the typical organization has a legacy infrastructure where they rely heavily on blocking the known bad. But instead, AMP works a little differently. When a file comes in, whether it comes in through email, downloaded from the internet, or sent across a network, we're going to continuously monitor and record that activity. And this integrated architecture is what has allowed us to reduce the time to detection down to 4.5 hours when used in conjunction with a technology like firepower. So all this recorded history, this threat analysis, doesn't just make detection and remediation easier for the customer, it also supercharges their existing infrastructure to be more agile and to respond faster to an incident. So this continuous monitoring and having a single threat intelligence source means that when we see something in one place, we can detect and prevent it everywhere. So this functions as a single control plane across the environment, which is something that the modern security infrastructure typically does not have. But having this single control plane makes automating an environment-wide threat response very fast and simple. And AMP is integrated across our own security portfolio. We have numerous third-party integrations for products like ThreatGrid, but the AMP portfolio also has open, extensible APIs for customers that want to tie in with their existing investments in their security infrastructure. So at the same time that AMP reinforces that environment, it also empowers security teams to act faster and decrease the impact of an incident. Now, a lot of customers don't really want to hear about breaches. They want to talk more about incidents because they don't want to acknowledge that they've had a breach, or more commonly, they think that a breach is something that happens to Target or Home Depot or Yahoo, and it's not really something that's going to happen to them. So for these customers, let's talk about how AMP will allow them to spend less time chasing noise and more time getting to the real incidents that matter so they can investigate those quickly and accurately. And this all adds up to AMP being the most effective security architecture. Now that we've talked about the AMP Everywhere concept, we're going to drill in on two focus areas today. The first is we're going to talk about AMP for endpoints, how it works and how it supports that security architecture. And next, we will cover ThreatGrid, which is the malware analysis engine that's built into every AMP license. So first, let's dive into the solution overview for advanced malware protection. Now, what is AMP for endpoints? Very simply, it's a next-generation endpoint security solution that gives us visibility, context, and control. It's software as a service, it's cloud managed, and it's deployed using a lightweight connector for endpoints that are running Windows, Mac, Linux, Android, and iOS. We're actually the first and currently the only company in the world that has a co-developed solution with Apple for iOS devices. And there's three things we want to do with AMP. The first is prevent attacks and block malware at the point of entry. And this is a solution that lets us replace the point-in-time detection capabilities of an antivirus. I'll talk more about that when we get into positioning. Secondly, we can decrease time to detection through that continuous monitoring concept with retrospection, with agentless detection, and with that integrated threat defense model. And that allows us to respond quicker and more effectively using a simple cloud-based user interface to scope the attack, to hunt for threats, and to surgically contain and remediate across all endpoints in just a few clicks. So let's talk about how we can use AMP to prevent attacks and block malware using our prevention framework. AMP for Endpoints has several technologies built into it that work together to prevent detect and remediate malicious code on the endpoint. Now, if we look at the time that it takes to detect an advanced threat, one thing is obvious: the shorter that this time is, the better. So because of that, let's start by looking at the in-memory prevention capabilities. And these are exploit prevention and system process protection. These are two engines that were added into the Windows AMP connector, starting with version 6.0.5. Now, exploit prevention defends endpoints from memory injection attacks that are commonly used by malware and other zero-day attacks on unpatched software vulnerabilities. It currently protects most common processes from being exploited. These are processes such as Microsoft Word, Excel, Outlook, web browsers, TeamViewer, Microsoft Task Scheduler, and others. System process protection is the other half of this, and this provides defenses to critical Windows system processes such as the Local Security Authority Subsystem, or LSAS, Session Manager Subsystem, Windows Logon, WinInit, and a number of others, by preventing compromise of these processes through memory injection attacks by other processes. Next, let's take a look at our on-disk capabilities. So when we're looking at malware that's actually made it to the file system, we can defend against those using things like the AMP Cloud that provides access to our global intelligence database. This is constantly updated and augmented with new detections, a great breadth of knowledge through one-to-one hash lookups, generic signature engines, and the machine learning engine. And this gives us both point-in-time as well as retrospective detection capability. We can also look at malicious activity protection. This is a new engine that provides real-time detection and blocking of abnormal behavior of a running program on the endpoint. For example, any behavior that's associated with ransomware. And we can actually get in there and we can block that as it's occurring. We also have custom detections. We deliver robust control capabilities to the security administrator by allowing them to define custom signatures and enforce blacklists across all their endpoints and of course, the rest of the security architecture. And finally, we have Tetra, which is a traditional signature-based antivirus engine, resides on the endpoint and provides on-disk detection capabilities if the AMP Cloud might not be reachable. Tetra is part of the AMP connector for Windows. We also have an offline engine for the Mac and Linux connectors that's running ClamAV. And finally, there's a very strong endpoint detection and response capability within the AMP agent. And this brings capabilities such as cognitive threat analytics, which uses machine learning and artificial intelligence to correlate traffic that's generated by users in order to reliably identify command and control traffic, data exfiltration, or possibly unwanted applications that are operating in the environment. Now, CTA requires a proxy that can supply web logs or a StealthWatch flow collector supplying NetFlow records. We also have device flow correlation, which allows AMP to monitor network activity and determines what action the AMP connector should take if a connection to a malicious host or network address is detected. And finally, we have cloud indicators of compromise that monitor patterns of malware and suspicious behaviors on the endpoint to alert if something strange has been observed. For example, if there's an event where Microsoft Word is launching PowerShell to execute an application. Of course, we recommend to use all of these engines in conjunction with each other to leverage the full value of the product, but customers can select whether to enable or disable one or another engine through a policy. Now, while listed separately here, these technologies work together as a protection lattice to provide improved visibility and increased control across the entire attack continuum. Now, let's spend a few minutes discussing each of these engines in a little more detail. I'm going to start with exploit prevention. So memory attacks penetrate via endpoints, and malware often tries to evade security defenses by exploiting a vulnerability in an application or in an operating system process. And many of these attacks actually operate in the memory space of the exploited application and remain untouched by most security solutions once they gain access to that memory space. So our AMP for Endpoints exploit prevention provides an additional layer of security for securing endpoints, servers, and virtual environments from these fileless or memory injection attacks. And it does so by changing the static nature of the defense landscape to a more dynamic one. It makes it more difficult for attackers to plan and execute successful attacks. And it works together with system process protection, which evaluates desired process or thread access and then can truncate potentially dangerous access from the desired access list before invoking that original system call. And this is designed to protect things like, again, the Session Manager subsystem, or SMSS, the Client Server Runtime subsystem, LSAS, Windows Logon, and Windows Startup applications. Next, we have the AMP Cloud. We've been using the AMP Cloud since the very inception of this product. It has a number of engines that supply its file reputations and file dispositions, from one-to-one signature matching to fuzzy fingerprinting using a technology we call Ethos, as well as machine learning, which is an algorithm called Spiro. And these give us a number of capabilities like file matching, which is very fast and computationally inexpensive, or polymorphic detection using a fuzzy fingerprint, which can convict polymorphic variants of a particular file based on structural similarities. And then Spiro, which gives us the ability to detect malware in a Microsoft executable using a zero-day detection without having to upload the file into a sandbox, which of course would take more time. So this is a more instant method of detecting malware that might be obvious through a machine learning approach. This is going to be supplemented with our malicious activity protection engine. This is the newest engine that we have released into beta today. Now, ransomware is one of the more prolific cybersecurity problems that we've been dealing with over the past decade. And our researchers have analyzed millions of ransomware variants to identify common techniques that they use for file encryption and the other things that they're trying to do with that ransomware. The result is this new malicious activity protection, or MAP engine, which will protect your endpoints from being encrypted, prevent propagation across the network, and keep the business safe from ransomware. So ransomware attacks can take many different shapes and forms, but most ransomware variants are typically going to try to encrypt data on endpoints and servers. And our MAP engine will identify those malicious actions of processes as they execute and stop them from encrypting data, because it detects threats by observing the behavior of those running processes, so it can determine if a system might be under attack by a new variant of ransomware that may have eluded other security products and detection technology. We also have custom detections, and these give control of the environment back to the security administrator, a very quick way to convict files that are unwanted or to initiate a cloud recall, restoral from quarantine across the enterprise. You can also write more advanced custom detections using the ClamAV signature language if there's an advanced use case the customer wants to address, and they have the capability to write into that signature language. We have an antivirus engine, like I mentioned before. That's Tetra for Windows or ClamAV for macOS and Linux. And this is going to replace the point-in-time detection capabilities of a legacy antivirus to allow customers to check that box to maintain that level of protection for a compliance audit, but also take advantage of the other detection engines that we have within the protection lattice. Let's talk a little bit about cognitive threat analytics. This is a very interesting capability that uses an artificial intelligence engine to process a massive amount of data in near real time to discover anomalous or malicious network activity that might be indicative of a breach. Now, CTA can analyze user and device behavior as well as web traffic to identify malware infections, command and control communications, data exfiltration, and potentially unwanted applications that are already operating in the organization's security infrastructure. CTA has multiple layers of processing, so we can use techniques like artificial intelligence, machine learning, and statistical models to learn the normal network in order to identify malicious threat activity. So the CTA engines are going to gradually build a notion of what is anomalous first, and then classify actual individual pieces of malicious activity to arrive at a final conviction that, yes, this device or this user is infected with some new form of malware. And with this analysis and correlation, we're able to bring small pieces of evidence together to finally convict each infection. And most of the infections that CTA identifies have typically bypassed other security controls or have entered through an unmonitored channel like removable media and are operating inside the organization's environment. And this gives us a few benefits. We get agentless detection with visibility into devices that might be running unsupported operating systems that can't run the AMP for Endpoints connector, like Internet of Things devices. We can get about 30% more detections using traffic from fileless and memory-only malware. And we can make investigations easier and faster for the security administrator by linking these cognitive threat analytics detections with AMP for Endpoint events, files, and processes to give actionable intelligence. CTA will produce a report that includes a priority rating and a human-readable threat description with a recommended course of action for each identified threat campaign. With device flow correlation, we get a kernel-level view into network input and output. We can block or alert on network activity and trace it back to the initiating process. Now, this is powered by our Cisco Security Intelligence feed, actually a subset of that SI feed, containing generic CNC servers, phishing hosts, zero-access CNC, and botnet hosts. And the final engine that we're going to talk about is the cloud indicators of compromise. We're keeping track of a number of behaviors that are known to be malicious or at least suspicious across multiple processes on a single host. We can correlate those using our cloud engines to automate whether we identify or determine whether something could be related to a malicious activity. And this is going to help the user prioritize the list of compromised devices if there's a number of things happening within their environment. So now that we've talked about preventing and detecting malware, let's talk about how we respond to malware once it's hit the environment. So with continuous analysis, we're continually going to watch a file or a process, even if we think that it's good, even if we have a good file disposition. After it's made it onto the endpoint, we're going to keep monitoring, recording, and analyze all that file activity. So if we detect a threat using some new threat intelligence or a new behavior that we're identifying, we can find out, where did this come into the network? How did this get into my system or onto my network? What is its rate of progression? Which systems has it gotten to, or where else has it been within my network? We can see exactly what it's doing on each system, and we can automatically or manually remediate that malware. And this enables what we call retrospective security, which is our ability to roll back time on an attacker and find out everything that they've done within that environment up until the point where we detected that piece of malware. And with a concept called AMP Unity, we are able to correlate all those queries and data within the AMP cloud and provide a global trajectory of files as they traverse across the network, or email, or a web appliance, and land on the endpoint. So with global outbreak control, you can do custom blacklisting and whitelisting within the AMP cloud, and we can have all AMP-enabled products honor these lists. And the concept is see it once and protect against it everywhere. I also want to introduce a concept called Cisco visibility. Now, visibility is not product configuration. It's actually a view into the data itself. It's a threat intelligence orchestration tool that's going to be delivered with AMP for Endpoints. It's currently in a beta right now. And we can deliver on this by creating this seamless experience as the user navigates between threat intelligence products. So they don't have to copy and paste indicators of compromise between different security dashboards. They don't have to open Notepad to keep track of incidents or lose context as they switch between views. They can pull in all of this threat data from a number of different modules, whether it's AMP, Umbrella, Threat Grid, even external sources like VirusTotal, and they can see how many times have we seen this particular indicator, where else have we seen it, is it seen just within my environment or is it seen globally? And they can pivot into each of these other products for additional analysis. And this is being driven through focused integrations between all these different products and with the Cisco visibility concept itself. One of the things that we can do with visibility is we can take threat data and we can take files that we've identified and we can pivot into the Threat Grid sandboxing solution. So let's talk a little bit about Threat Grid right now. Threat Grid is a high-fidelity security intelligence tool that gives analysis reports as well as decision support. So, we think that something is malware, but why do we think it's malware? Why do we make that decision that something is bad? Well, we can get support for that decision by looking at that Threat Grid sample report. We'll provide threat scores from 0 to 100 to provide context beyond a typical binary good-bad decision. And we're going to give human-readable behavior indicators to see exactly what that sample tried to do in the virtualized environment. And we do this using an outside-in approach. I'm going to talk about this in just a moment. So we have virtually no presence within the VM itself. And we use dynamic analysis with an external kernel monitor, with modifications to the logical disk, with user interaction playbooks, video, process information, and so on, to provide a very comprehensive picture of what this sample is and how it works and what it did within that sandbox iteration. We have a large number of integrations with ThreatGrid. This is just a subset of them. ThreatGrid was actually designed around APIs. When we acquired the ThreatGrid company, their bread and butter was creating OEM integrations into other security products, and we've maintained nearly all of those moving forward. So any product can submit into ThreatGrid for analysis and get the report and get the score back. We've built ThreatGrid on the premise of having intelligence and added context with indexing data. So if data is not indexed and searchable, then it's not very useful. So we index and provide everything for searchability. So let's look at how we can submit samples into ThreatGrid. We have about 104 million samples in the cloud right now. Most of them are coming from AMP-enabled devices. And that's going to be email security, web security, AMP for endpoints, network, a large number of submissions coming from each of these sources, as well as the ThreatGrid API and the ThreatGrid console itself. And once each of these submissions hits the ThreatGrid product, it's going to be subject to static and dynamic analysis. Static analysis is looking at the file as an isolated entity. It's looking at header details. It might be looking at what antivirus engines conclude about the file, basically what this file is and what it contains. Whereas dynamic analysis is looking at what it does with network connections, with file system changes, with function or library calls. What is this file actually doing within the environment? One of the techniques that we use to accomplish this is our kernel monitor. This is outside and invisible to the guest operating system. We can map interesting symbols to select kernel functions. We can set hardware traps to analyze data that's coming in through those kernel functions and then extract interesting content or any interesting arguments that we find. And the result of all this are going to be displayed in the analysis document, or the JSON document that we're going to send for future enrichment or further enrichment into the product. So this is all going to be displayed as part of our behavioral indicators. Now, there's a few problems that we're dealing with in the context of malware analysis and ThreatGrid. The first problem is, for some reason, malware authors really don't like us analyzing their samples. They really don't enjoy this very much. So one of the things that we have to do is deal with that using maybe techniques like the outside looking in approach, which I'm going to talk about in just a moment, or user interaction with playbooks, which I'll talk about again as well. But there's a lot of malware out there that contains functions and calls to try to see if it is running within a virtualized environment, if it's running within a hypervisor, if there's any user activity, if it's part of any known VM or sandbox environment. So this is one of the first challenges. The second challenge is malware authors have a wide variety of file types at their disposal that they can use to deliver malware. A number of really interesting file types beyond just typical portable executable functions like EXEs and DLLs. They're using MIME HTML, they're using Flash, they're using PowerShell and Visual Basic scripting. So we have to deal with a tremendous variety of malware file types, as well as new delivery vectors like Excel scriptlets and sub-documents within Office documents and so on. And these are often intended to bypass code identification or use some functionality that may not be present within a typical sandbox environment. Fortunately, our developers have come up with a number of solutions like user emulation playbooks, classification, and network exit localization to deal with these challenges and get us a high-fidelity environment that will detonate nearly all malware that we can find. So first, the ThreatGrid malware analysis solution doesn't actually use any instrumentation or debuggers within the environment. It doesn't modify the operating system capabilities to monitor sample activity. This is why we use an outside looking in approach so that the sample itself can't see any modifications that are made to the environment. Where most competitive malware analysis engines require hooks or device drivers or operating system settings to be modified, which malware developers can see, and we're increasingly seeing malware looking for those signs of a sandbox, we can actually detect those activities when malware is looking to enumerate whether it's in a sandbox. We can record those as suspicious, and we can actually trigger on those with our behavioral indicators. Now, ThreatGrid operates outside of the virtual instance malware is running in, which means that we can see all activities, including file system changes that other competitive solutions may not be able to detect. And our outside looking in approach is going to help us defeat things like debugger checks. One of the things that we can do is use user activity using playbooks to simulate user activity, things like mouse cursor, random movement, opening the start menu, clicking into things. There's 9 different user emulation playbooks currently in the product to help defeat malware user activity checks. We also have standardized file identification, forensics, and pre-classification to help to defeat the second problem, which is the increasing breadth of file types that are in use by attackers, as well as that third problem, which is the variety of exploit and propagation vectors, as well as lowering licensing costs. Now, we accept all file types for static analysis, but uncommon file types may result in uneven results. So our research and efficacy team is constantly updating their models to reflect changes in the threat landscape and in attacker methods and tactics. So static analysis can determine whether a file is reasonably good or not, and whether it should be sent for a dynamic analysis. We don't use it to determine whether a file is bad, although that may be an end result of that process. And added most recently, we have network exit localization to help mask the true origin of a running sample. And this allows ThreatGrid to observe how location-aware malware might behave differently depending on that observed location. It's also a mitigation for the first problem, which is sandbox-away malware. So because some types of malware are going to be designed to behave differently depending on geographic location, while other types may target a specific area, our network exit localization makes any outgoing network traffic that's generated during that analysis to appear to exit from one of a number of locations that we have built into the tool today. Now let's talk a little bit about positioning. The first concept I want to give you is for non-security focused buyers. These are buyers that recognize the need for security, but they may not be anti-malware experts. They may not be security engineers by trade. And one of the ways that we can position AMP and ThreatGrid into those accounts is by looking at AMP for endpoints first to maybe replace an antivirus or give additional protection to the endpoint. We can add Umbrella with AMP. We can add Meraki or some other simple network-based device with AMP capability. And then we can add ThreatGrid Advanced File Analysis to give them additional samples and move them into a ThreatGrid organization. Conversely, with a more security-focused buyer, we can start with something like email security with AMP enabled. Enabling ThreatGrid file analysis with email security actually triples the number of sandbox-detected malware samples that can be blocked in line in that email security appliance. Once we have that, we can talk about ThreatGrid. We can move into AMP for endpoints and Umbrella, and we can look at that security architecture. Now, most of your customers are probably going to ask you at some point, can AMP replace this antivirus that I'm running today? And the answer is yes, but we have to make sure that that is the right question to ask for that environment, because there's a number of use cases that customers may want to solve with their antivirus, and AMP may or may not be covering those use cases. So first of all, AMP does contain an antivirus engine. However, AMP does not include disk encryption, endpoint DLP, a free toaster oven, or anything else that antivirus companies have been bundling in to help sell their aging security software. However, AMP's protection, detection, and response capabilities are far more advanced than traditional antivirus. So the key here is not to compete strictly on price per endpoint or price per seat, but to look at the actual capability of AMP. But yes, antivirus is a subset of those capabilities. Now, when looking at positioning ThreatGrid, all AMP-enabled devices, that's email, web, firepower, Meraki, and so on, can submit into ThreatGrid and give static and dynamic malware analysis. And that helps to discover new threats and so on. But positioning a ThreatGrid cloud subscription gives so much more functionality, including enhanced reporting so that customers can pivot and drill down on all of these data elements. A global and historical view of all samples submitted, not just by their own organization, but every sample that ThreatGrid has ever seen that's publicly accessible. And this allows analysts to really dig into those investigations, discover multi-stage attacks that might be part of a larger targeted campaign, and also provides access to an API that seamlessly ties in with their existing security infrastructure, whether it's Cisco or not, all the way from firewalls up to a CM platform. Now, if we're looking at sizing ThreatGrid, every AMP-enabled device, any purchase of an AMP-enabled device is going to give a customer access to 200 included ThreatGrid submissions. That's going to be shared across any number of those devices. So even if they have just the minimum licensing of AMP for endpoints, or if they have a very large deployment of next-generation firewalls, they're going to get access to this starter pool of 200 licenses. And we can add something like ThreatGrid Cloud to that, which gives the API integrations, it gives the front-end analysis platform, and we can supplement with additional advanced file analysis licenses to add additional capacity to that ThreatGrid organization. So let's talk about positioning ThreatGrid. Who's a good prospect for ThreatGrid? Well, almost everyone, really. If they're a technical analyst or an incident responder, they're going to be aware of the capabilities of this ThreatGrid solution, and they might be looking to boost the capabilities of their existing security architecture. Now, if they're on a mature security team, like maybe many customers in the financial and banking industry or insurance and so on, we can talk about how it offers automated malware analysis. It integrates with their existing infrastructure. It gives them that deep capability for those tier 3 analysts and context-rich analysis capability. Conversely, if they're looking for a solution to provide resource-constrained capability, if they're a smaller organization, maybe they're a state and local government, we can talk about how ThreatGrid is integrated with their existing Cisco security products, how it can empower junior analysts to punch above their weight class because of the additional enrichment that we give them, and also the low OpEx that we get with a cloud software as a service model as opposed to having to sell appliance-based sandboxing solutions. All right, now the final section, we're going to talk about AMP and ThreatGrid design, both for public and private clouds. So first, let's take a look at how this works. Sandboxing is not a standalone security measure here at Cisco. We try to integrate this technology into existing products. So we have the ThreatGrid sandboxing service that's combined with the AMP service or file reputation service, which is a cloud database that keeps dispositions for known malicious and clean files and can indicate if a file is unknown or has never been seen before. And these services are always leveraged in conjunction. So the results of ThreatGrid file analysis are going to be fed into AMP using a file disposition update. And this creates a global engine that's analyzing hundreds of thousands of files and marking them automatically. And that makes our AMP solution very unique. But we also have access to the Cisco Talos organization, which takes telemetry and threat intelligence from each of these cloud platforms, provides further automated and manual analysis, and generates updates not just for AMP and ThreatGrid, but also for all Cisco security products. So Talos can mark malicious files within AMP, create indicators of compromise and machine learning detections, and write new behavioral indicators for ThreatGrid. All right, so looking at the solution overview, the services we have are file reputation with the AMP Cloud, file analysis with the ThreatGrid Cloud, and file retrospection, again, with the AMP Cloud. We can also deploy private clouds and on-premise appliances for customers that need those. And if we look in terms of the integrations across all these named products here, each of them have access to file reputation services. Nearly all of them have file analysis, some of it's in the works, and as well as file retrospection. So talking about those deployment modes, whether it's cloud-based or on-premise, we have a number of those different deployment options for AMP Cloud as well as ThreatGrid Cloud. Starting with AMP for endpoints, the cloud-based version of AMP for endpoints is the simplest to deploy. It's what most customers are already familiar with. So the AMP connector is going to use the AMP Cloud, the public AMP Cloud, for file reputation checks, to receive file retrospection, and also to submit analysis requests for a file and get the results back using that file fetch and file analysis report capability. Now, if we deploy into proxy mode with our private cloud, all of the AMP connectors within that environment are going to consult the AMP private cloud virtual machine first. And if the virtual machine doesn't know anything about that file, it can consult the AMP cloud directly. So the only connection that's going outside of the organization's perimeter is going to be coming from that AMP private cloud VM up to the AMP cloud. But otherwise, everything happens as normal. The private AMP cloud can consult with a threat grid appliance for all of the file reputation or the file analysis and sandboxing capability that we would normally have in the AMP cloud. Now, if the customer deploys into air gap mode, they sever that connection between the AMP private cloud and the global AMP cloud. There is no longer file reputation. There's no longer file retrospection because those are capabilities that are sourced from the global AMP cloud. But otherwise, everything's going to happen locally. The customer will have to download a recurring update to the AMP private cloud that takes all of the disposition changes that we've made on the public cloud side so that they still have access to that ongoing updated threat intelligence. Now, if we look at the network side of Firepower Management Center, it works in much the same way, slightly different communications pathways because the AMP connector is actually the one that's submitting the file, whereas the Firepower Management Center, or the FMC, is doing the file reputation checks on behalf of the individual AMP connector. But there's an interesting model for the network hybrid where you can have the public AMP cloud and submit into a local private threat grid appliance. You can do this. However, I don't always recommend doing it because the malicious file hash, if we have a threat grid appliance that comes back with a high threat score for a file that would allow us to convict that file as malware, that threat score is not going to be reported up to the AMP cloud. It's not going to be automatically marked in the global AMP database, which is a drawback because the next time we see that file, we haven't seen it before from the AMP cloud's perspective, so we're not going to get the advantage of having that detection from the threat grid, which we would if we had deployed the normal private cloud proxy mode. Again, this works the same way as AMP for endpoints. The malicious file hash is not going to be automatically marked in the global AMP database, but it will be updated within the private cloud. And then in air gap mode, again, we lose the file reputation checks, we lose file retrospection, but this is useful for those customers that have to have a extremely security-focused deployment, and they can't have any communications going outside of the organizational perimeter. With email and web security, very similar to what we just discussed, the AMP connector for email security appliance, cloud email security, or web security appliance will do those file reputation checks, will do those analysis requests, and receive the analysis reports directly from the threat grid cloud. You can deploy into a hybrid mode, but we do not recommend it because that file hash will not be automatically marked in the global AMP database. Instead, let's position the AMP private cloud to be able to get access to that, which will also allow us to whitelist files if they are not actually malicious, even though they really appear to be within the sandbox. And then air gap as well. So if we look at these in another way, we have a little matrix here. Public cloud with threat grid cloud, absolutely. Recommended deployment option. If they have high privacy requirements, like some Defense Department or governmental agencies, then maybe consider the private cloud with threat grid appliance. Otherwise, let's lead with the full public cloud solution. Running the public cloud AMP with a private threat grid appliance is technically supported, but has some drawbacks because the threat grid appliance will not communicate with the global AMP cloud. It doesn't share those analysis results. So the architecture doesn't get to take advantage of what we just did there. And then finally, the last use case is having the AMP private cloud submit files into the global threat grid cloud. That just doesn't make sense. It's not supported. Nobody's going to want to do that. So there you have it. That's the design session. And I have just less than a minute left, so I'm going to actually turn this back over to our session host, and we will be available to answer some questions if you still have them within the Q&A panel.
All right, great. Thanks, Daniel.